Hi everybody. As you know, a firm is financed through two basic main categories. They either go through debt financing, through bonds, which we are going to cover today, and in 2 weeks we are going to cover stocks. So they can be either debt finance or equity finance. We are going to start looking at debt finance and specifically issuing bonds, and we are going to calculate the value of a bond given specific types of features. Now, we know the time value of money operations, and we know how to calculate the interest rate. With these two tools, we are ready to tackle the problem of calculating the value of a specific bond. Bond, again, is a long-term debt instrument where the borrower agrees to make payments of principal and interest. Bond markets are primarily traded over the counter, and you can see from Wall Street Journal is a great place to look at the key developments in Treasury, corporate, and municipal bond markets. Now, one thing important, par value is equal to, in bond terms, the future value. If you look at chapter 5, the time value of money operations, it is the future value, and it's always $1,000 in the US unless given otherwise. So a $1,000 bond means the face value or the par value is $1,000. Now, the interest rates get complicated here, and the reason for that is there are different interest rates. One is coupon interest rates, that is to calculate the coupon payments, and in the past, before the digital era, bonds literally had coupons where you go every 6 months or every year, usually every 6 months in the US and every year in Europe. In European countries, it's on a yearly basis. You go and they pay you a specific amount. So this coupon interest rate will tell you what the coupon dollar amount will be. In chapter 5 terms, this calculates the PMT. So if the coupon interest rate is 5%, on a $1,000 bond, you are going to get $50 in each period. Maturity date is year. In chapter 5 terms, it's N, the number of periods. Issue date is usually today when the bond is issued, unless otherwise indicated. Yield to maturity is important. That is the the interest rate from chapter 5. So let's write these again with from chapter 5 perspective. This is future value. This is going to calculate your PMT if there are regular payments. PM and T, and your maturity date and issue date is going to give you N together. Yield to maturity is I, the interest rate. So again, as you see here, there's a kind of interest rate here and here. The actual interest rate you are going to use that the market demands is yield to maturity. That is important. Yield to maturity here given for n periods of time. The value of a bond is nothing but the cash flows you are getting in year 1 through n. And usually what's happening is you get payments for each year, and at the end of the year you are going to get the last coupon payment plus the $1,000 or the face value if it's otherwise indicated, if it's different than the future value. Now, how do we calculate the discount rate? The discount rate again is yield to maturity. That's important, and in that the market demands a real rate, the market demands an interest premium, maturity risk premium, default risk premium, and liquidity premium. That is the opportunity cost, that is the yield to maturity. Everything leads to the same fundamental idea that this is the I in chapter 5 terms. So this is the interest rate that the market is demanding. Now, coupon. Let's take a look at one example where the value, we are trying to calculate the value of a coupon that is 10-year bond, 10% annual coupon, and this is the coupon rate to calculate PMT. This is what the market demands. The market is demanding the same as the coupon rate in this particular example. Not always, but in this particular example. If we do the math, then the value of the bond is $1,000. So the face value is 1,000. The present value of this type of cash stream with 10% interest is going to be $1,000. Now, why is this example important? Because we are going to compare that to other examples. Now, let's assume that we have the same 10-year bond. It has the same risk, which means the market again demands 10%. But it pays 13% annual coupon. So the payment on $1,000, 13% is $130 each year. You are getting more payments this time compared to the other example where you are getting 10% coupon, so $100. When you do the math, you are going to find that the value of the bond is $815 or $816 roughly. And the reason why it's lower than $1,000, why you are paying less, is because you are getting more payments. So the value of this bond specifically turns out to be $1,184. And the reason why it's more than $1,000 from the previous example is you are getting more. Instead of getting $100 each year, you are getting $130 each year. So you need to pay more. Compared and contrasted to 7% coupon, where you are going to get $70 each year, then you are getting something less than $100, you need to pay less accordingly. Remember, the original was 10-year bond with 10% coupon. This is 7% coupon. So instead of getting $100, you are getting $70. Hence, you need to pay less. If you want to calculate year to maturity of the bond, of a given bond, let's say 10-year, 9% annual coupon, this is pretty much standard. Future value is $1,000, selling for $887. What we are really doing is we are solving for the interest rate. I'm going to write this as a problem where we are going to say, okay, N is 10. PMT is 9% of 1,000, 90. 90 is PMT. Future value is 1,000. Present value is minus 887. And you either hit on your calculator the I button, the interest rate, or you do the rate calculation. Type in rate. N is 10. The PMT is 90. Present value is minus 887. You are paying cash outflow. Hence the sign is important. And you are getting back $1,000. We can do it for different bond prices to find the different rates. And in this example, the bond price was $1,134. When we are trying to calculate the interest rate, turns out to be 7.08% interest rate is needed to solve this particular example. Now, as I mentioned, in the US, the bonds are a little bit different in the sense that they are paying semi-annually. So let's take a look at those. For semi-annual bonds, what you need to do is multiply years by 2 to find the number of periods. Because if the bond is semi-annual, 1-year bond, n is not going to be equal to 1, it's going to be 2, because you are going to get one payment in 6 years time frame, 6 months time frame, and another payment in another 6 months. So for every period you are going to get, for every year you are going to get 2n. You need to divide the nominal rate, and if you remember from auto payments, it was 5 years payments in chapter 5, and we multiplied it by 12 because it was monthly. So it's the same idea here. Semi-annual means not multiplied by 12 but multiplied by 2. Similarly, we are going to divide the nominal rate by 2. Remember, if you remember the car example, car amortization example, we were dividing the interest rate by 12. In this case, semi-annual payments, we need to divide the interest rate by 2. Similarly, payment is going to be annual coupon divided by 2. So if the annual coupon is 100, then what it means is in 6 months you are getting $50, in another 6 months you are getting another $50. The rest is pretty much the same, and let's apply it to a specific example, just because it's important for as in the US it's calculated on a semi-annual basis. What is the value of a 10-year bond that is 10% semi-annual, and if the interest rate is 13%? Now, number of periods is 20 because it's semi-annual. For each period, the market is demanding 6.5% interest rate. For each period, 10% coupon rate, which is $100. For each period, you are getting $50. Now, n is 20. The interest rate that the market demands is 6.5. 13 divided by 2. Skip payment, you are going to hit on it at the end. PMT is $50. It's like we calculated here, and future value, as I mentioned earlier, is always 1,000. If you do the math, we are going to calculate the value of the bond is $834.72. Last piece I want to talk about here is the evaluating the default risk. As I mentioned earlier, in interest rates, the riskier the investment is, the more interest you are going to demand. So the I, the interest rate, or RD in this case, yield to maturity, is going to increase as the risk increases. And there are different firms who are evaluating the bond risks based on different criteria. What they say is they put it into investment grades. AAA bonds are pretty much the safest bonds, and it goes all the way to junk bonds where the risk gets higher and higher as you move in the spectrum. So to recap this class or this bond exercise, it is pretty much to calculate the value of the bond is pretty much a time value of money operations, where you get the PMT, the payment, as coupon rate. The interest rate that the market demands is important. It's yield to maturity, and then you calculate the number of you take the number of payments, and you either calculate the present value, which is the value of the bond if you go to the market and want to buy it today. So that's what you are going to pay, and future value or par value usually is $1,000, unless given otherwise. That is pretty much it that I want to cover for chapter 7, and next week we are going to cover chapter 8.